Good morning, students. Today's topic is refraction by a lens. So here we are trying to derive an expression for a lens maker's formula, a relation between focal length, refractive indices and radius of curvature, or radii of curvature of a thin lens. So let us consider a double convex thin lens. So AC is the aperture of this lens here. So you can see that N1 is the refractive index of the surrounding medium, whereas N2 is the refractive index of the lens medium, which may be is a glass. So if it is glass, N2 is 1.5. N1, if it is air, then it is 1. Now let us consider how the image formation occurs. This is the principal axis, which is a line passing through the optic center and the centers of curvatures of the two surfaces here. So B and D are the poles of the two surfaces. Now the image formation happens in two steps here. So first refraction occurs at first surface, then refraction occurs at the second surface. Let us try and understand step by step. So let us consider an object, point object O, which is at a distance U from the optic center of the lens. Then the second surface is absent. So let's say only first surface is there. So right side medium is completely the glass medium, the denser medium. Now any ray which emanates from O hits the surface here and undergoes refraction and bends. Instead of going straight, it will bend towards the principal axis. Similarly, another ray going from the object O through the optic center goes undeviated like this and meets the previous this blue colored ray at this point here where the image formation occurs. I1 is the image formation. This is due to refraction at a single curved surface. Whereas in the presence of the second surface, that is the right side medium now is air, so second surface is present. The ray which is inside the medium here, glass medium here, so gets once again refracted at the second surface, so one more bending occurs. So that gives rise to the new image, that is I. So image I1 has a distance V1 from the optic center, image I has a distance V from the optic center. So now what exactly happened? Object O created an image due to first surface at I1, which becomes the virtual object for the second surface, producing the final image at I. So let us try and understand this in steps and derive the lens maker's formula. So first I'll consider the first stage, that is the lens, the principal axis, B and D are the poles, the object is at O, U is the object distance, C1 is the center of curvature for this first surface, R1 is the radius of curvature for the first surface. The distances are all measured now from the optic center. Of course, from the pole you can measure for the first surface, but B, D or the center of the lens are considered to the same point because the lens in consideration here is thin, very thin lens. Now, any ray which emanates from O hits the surface at some point here. So second surface is not there, remember that, only one surface is there. Now the ray will not go straight like this as expected. So it will bend actually. So to understand the bending, we need to draw a normal at the point of incidence. So normal is a line passing through the center of curvature and the given point. So this is the normal here. Say N1 is a point of incidence and I1 is the angle of incidence for the incident ray, angle between the incident ray and the normal. Now this ray, instead of going straight, it gets bent towards the normal because it is turning from rarer to denser. So the ray hits the principal axis at some point here. The angle of refraction is R1, angle between normal and the refracted ray. Now this ray and another ray which passes through the optic center goes undeviated, meets the previous ray here, creates an image I1. This is the image formation because of the first surface in the absence of the second surface. Now here this is refraction through a single surface. So write the refraction formula. Very easy. You have object space refractive index by object distance plus image space refractive index by image distance is equal to difference in refractive indices by radius of curvature. So N1 is the object space refractive index, the space in which the incident rays are present, where the object is there. This is the incident ray N1 and minus U, object distance, plus image space refractive. Image is in denser medium where the refractive index is N2. So N2 by image distance, that is I1 distance is V1, which is equal to image space refractive index minus object space refractive index N2 minus N1 by R1. R1 is the radius of curvature of the first phase. This is the refraction formula applied to the first phase. Now let us just keep this diagram aside. First stage is over. Now let us understand the second stage. So I will start from the first stage. Already image I1 is formed. Now this image acts as a virtual object for the second surface producing the final image. So let us consider the second surface now. The moment I say second surface is present, then the right side medium is no more denser, it is a rarer medium. So now second surface is present, ADC. The ray which is inside the glass medium, that is here, instead of going straight to I1 creating the image, it will actually undergoes refraction once again. To understand the refraction, let us draw a normal. Center of curvature C2 for the second surface, R2 is the radius of curvature. Line from center of curvature to the given point, that is normal. Now the ray, instead of going straight, it gets bent. Angle of incidence is I2. The bending happens here, that is away from the normal actually, because it is from denser to rarer medium. So thereby angle of refraction R2. Now another ray, of course, which went through optic center meeting the first ray here, new image is formed, that is I. So I1, which is at a distance V1, it is now actually not there, it is virtual. Now where is the final image? I, which is at a distance V. So I1 acts as a virtual object for the second surface, and I acts as the final image, the real image, due to the second surface, refraction through the second surface. Now let us keep this aside and apply the refraction formula for the second surface now. Refraction formula is what? Same thing again as we did in the first case. So let's consider object space refractive index by object distance. That is object space. Where is object? Object is I1 here. I1 is the object which is in the denser medium. You can see here it's a glass medium. So now it is virtual, so it is supposed to be in the denser medium. So object distance is V1 and object space refractive index is N2, the denser medium's refractive index. So N2 is the refractive index of the object medium, object space refractive index divided by object distance, that is V1. So negative sign is with the general expression actually. So then plus image space refractive index. Where is image formed now? I1. I1 is the image, final image, which is in the air medium, that is in the presence of the second surface. So N1 is the refractive index of this surrounding medium. So then final image distance is V. So V is the image distance, is equal to difference in refractive indices, that is image space refractive index minus object space. Image space refractive index is N1. Object space refractive index is N2. So N1 minus N2 by R2, which can be written as N2 minus N1 by minus R2. Just I am trying to match this N2 minus N1 with the previous equation. Now with this, so this is the final diagram. So both the stages covered here. So first phase refraction, then second phase refraction, final image formation. So adding these two equations, we get this. So here N1 by minus U, that is N1 by minus U plus N2 by V1 minus N2 by V1. These two get cancelled, plus N1 by V, N1 by V is equal to N2 minus N1 common in these two, 1 by R1 minus 1 by R2. This is the expression. What is this 1 by minus U plus 1 by V? This is 1 by F. This is according to thin lens formula. So according to the thin lens formula, this 1 by minus U plus 1 by V is 1 by F. This is equal to N2 minus N1. This N1 went down here into this. I have just written the same equation here once again. So then N2 by N1 is N21 minus N1 by N1 is 1. So N2 by N1 minus N1 by N1 is 1. So this N2 by N1 can be written as N21 minus N1. N21 is refractive index of the second medium with respect to first medium. So there is refractive index of lens medium with respect to the surrounding medium, minus 1, and this 1 by R1, 1 by R2 as it is. So this is called the lens maker's formula. So on this, a 3-mark question is asked. So derive lens maker's formula, and let me just tell you once again. See, this much, this is the thing required actually. So from here, lens maker's formula question is asked. So then consideration, image formation in 2 steps. First step, second step. For first step, derivation of the refraction formula. So then second stage, second step, so refraction formula for the second phase. So then adding the two and getting the final expression. Only 2-3 steps you can get this, and only diagram required is this. So you can see here lens is there, image formation through a lens, so incident ray, refracted ray. So intermediate step also is there, I1, which is the virtual object. So what is there on the screen now, except the video part here. So if you can just write this much, you are going to score 3 marks actually. So With this, an add-on equation will be there, either a short numerical or expression for power or something like that. So that will be for 2 marks. So totally a 5-mark question can be framed on this. So derive lens maker's formula by using a suitable diagram or relation between focal length of the lens, its radius of curvature and its refractive indices. So this will be a 3-mark question, along with which a 2-mark question can be added for 5 marks totally. So image formation in case of double convex lens. This is just to understand how the image formation occurs, I have a simulation here. So let me just show you a simulation. See, in this I have a slider to change the object distance. So this is object AB and A dash B dash is the image. Whenever you want to understand the image formation in the case of a lens, you have to consider minimum 2 rays emanating from the given object. So one is parallel to the principal axis. When a ray of light passes parallel to the principal axis, after refraction it always pass through the secondary principal focus on the other side of the lens. Then another ray you can consider is the one which passes through the optic center, and that goes undeviated without any deviation, the purple ray here. And another ray, if you want, you can take, that is the one which passes through the first principal focus, then it becomes parallel to the principal axis after passing through the lens. So 3 rays I have shown here. So at least 2 of them you can take for understanding the image formation. So now in this case here, say the 3 rays here, they are meeting at some point B dash. So A dash B dash is the image. So now if I keep the object distance to be exactly 2 times the focal length, that is at 2f I have placed the object. You can see that image is also formed at exact 2f on the other side of the lens. So magnification is 1. Exact same size is there, but inverted image. So inverted image, same size of the image is same, that is magnification is 1. On the other side at the same distance it is formed. Now if I increase the distance further, object distance I am increasing, see I am taking the object away. So you will find that the image comes closer and closer, and when the object goes to infinity, this image comes to the principal focus. But it is so much small, it is diminished actually, it is very small. So when the object goes to infinity, image comes to principal focus. Now what happens if I come between this one 2f and f? Of course, see magnification is more than 1, it is bigger than the object, image is bigger than the object, but of course inverted. If I further reduce, if I come to principal focus, you can see that the image formed is at infinity, the 2 rays are not meeting at all. Okay, so image is formed at infinity, but it is inverted. Further, if I reduce the distance, you will find that the image is, let me just reduce it here. So image is erect but virtual. The 2 rays here which I have taken after passing through the lens, they don't meet in front of the lens here forward because they are diverging actually. So extrapolate them back to meet and you see that they appear to be coming from B dash here. So therefore a virtual image is formed behind the lens, which is magnified of course. Now if I continue to reduce the distance, see you can see here like this, of course at any point it will remain virtual only like this. So when the object is between principal focus and the optic center, a virtual image is formed, and erect image of course, and it is magnified. Virtual, erect, magnified image is formed. So but if you keep the object at principal focus, the object image is at infinity. If you go beyond principal focus, the image is on the other side, the real image is formed, but it is inverted and magnified. But only when the object is at 2f, the image and the object will be of same size, that is magnification is 1, but it is minus 1, it is image is inverted actually. Further if I increase, of course you understood already. So this is how it is diminished image. Thank you all very much.